In this guide, how dynamic client registration lets OAuth clients provision themselves at runtime with a single post. No admin required. The exact request and response fields from RFC 7591 and the RFC 7592 management protocol. And the security boundary between open and protected registration, including software statements for high-trust deployments like openbanking. Identity Expert, powering you to be an expert in identity. Dynamic client registration, DCR. Normally, every OAuth client must be manually provisioned by a server administrator before it can request a single token. DCR flips this around. An application sends its own metadata to a registration endpoint, and the authorization server responds with a fresh client ID right there on the wire. No help desk ticket, no admin portal, no deployment gate. One HTTP post and the client exists. That is the core insight RFC 7591 gave us in 2015, and OAuth 2.1 has since adopted it as the preferred provisioning mechanism. Think of a hotel conference system. Old model. A sales team manually adds every company to the booking platform, paperwork, waiting, delays. Dynamic client registration is the self-service kiosk in the lobby. You walk up, present your business card, your company name, contact details, and requirements, and the system issues an account number on the spot. That number is your client ID. Your business card is the client metadata, redirect URIs, grant types, application name. The kiosk is the registration endpoint, and some hotels lock the kiosk behind an invite-only code. That code is the initial access token. Manual client registration creates real friction at scale. An API platform serving thousands of third-party developers cannot have a human approve each one. Mobile apps update redirect URIs constantly. Outdated registrations cause silent auth failures. Enterprise deployments run dozens of microservices, each needing its own client ID. And without a standard protocol, every authorization server offers a different admin UI or proprietary API. There is no machine-readable way to register a client that works across vendors. OAuth grew to cover these scenarios, but the base specification never described how client credentials were provisioned. RFC 7591 fills that gap. DCR works in 3 phases. Phase 1, the client sends a post to the registration endpoint, the URL advertised in as metadata under the key registration endpoint. The request body is JSON containing client metadata, at minimum redirect URIs. Optionally, client name, token endpoint auth method, grant types, and scope. Phase 2, the AS validates the request, assigns a client ID, optionally generates a client secret, and returns the full registered metadata. If RFC 7592 management is supported, the response also includes a registration access token and registration client URI for future reads, updates, and deletion. Phase 3, the client uses its new client ID to start a normal OAuth flow immediately. Here is what the wire looks like. The registration request, a post to /register with content type application /JSON. The body includes redirect URIs as a string array, token endpoint auth method, typically client secret basic or private key JWT, and grant types, authorization code for user-facing apps. The AS responds with 201 created, returning the assigned client ID, a client secret if applicable, the registration access token, and registration client URI. For RFC 7592 management, get the registration client URI with the registration access token in the authorization header to read current metadata, put with a full replacement body to update, or delete to deregister the client entirely. 3 threats dominate DCR deployments. First, open registration abuse. An unauthenticated endpoint means anyone can register rogue clients, potentially impersonating legitimate apps by mimicking client name and redirect URIs. Mitigation, require an initial access token that a trusted party issues before registration. Second, registration access token theft. This token grants full read-write-delete control of the client. Treat it like a client secret, store it securely, rotate it, never log it. Third, SSRF via metadata URIs. Fields like logo URI, JWTs URI, and policy URI trigger server-side fetches. Attackers inject internal service addresses. Mitigation, validate and allow list URI schemes and hostnames before the AS fetches any client-supplied URL. DCR is becoming mandatory infrastructure. OAuth 2.1 names it as the preferred client provisioning mechanism, elevating it from a standalone RFC to a normative reference in the base protocol. FAPI 2 mandates DCR in regulated financial ecosystems, augmented by software statements, signed JWTs issued by a trusted authority, that carry cryptographic proof of client identity. OID4 VCI uses DCR as the bootstrap mechanism for wallet clients enrolling with credential issuers under the EUDI wallet framework. OpenID Federation automates trust establishment across large client networks using DCR for leaf node enrollment. Any platform onboarding clients at scale should treat DCR as the default, not the exception. All primary sources cited in today's guide are listed on screen. You'll find direct links to the RFCs and specifications in the video description below. If this breakdown helped you understand the topic better, please subscribe to Identity Expert. We publish a new protocol deep dive every week. Thanks for watching. If there's a specific identity standard, authentication flow, or security protocol you'd like us to cover next, drop it in the comments below. We build our content based on what the community asks for. Subscribe and hit the bell so you never miss an episode.